Hi guys, I decided to do a very quick video on the Kirchhoff loop rule and the junction rule. So here you can see a circuit with two batteries, and I have named it as A, B, C, D, E, F, A. That is the closed loop, and inside the closed loop actually you see two other loops. Actually I am going to do a minor change here, and I'm going to add another resistor here, and I have it as 1 ohm or something like that. Now we can first decide a direction of a current, and as I mentioned in the class, if the direction is wrong we will end up with a negative value. So here I took it as I1. You can take it however you want it, I1, and then down here I have I2, and on this branch I have I3. So the first thing first, we are writing down the equation for the junction rule. So you have I1 equals to I2 plus I3. So this is my equation number 1. And after that, based on the current, we can mark the positives and negatives, right? So for the battery, the current direction doesn't matter. This is negative, this is positive. So based on the direction of the current around the 2 ohm, we can mark this end positive, that end negative. Again, the direction of the current over here is in the downward direction, therefore this is positive, this is negative. And there you have for the 3 ohm resistor over here, upper branch, this is positive, that is negative. And then here it doesn't really matter, that's a battery, plus and minus. And then again, if we take the direction of the current over here, I3, still I3, and this is a positive, that's a negative. And then the I1, I am using the red again here. I2 comes down to this point, and I3 from that branch comes down to this point. And then again the junction rule should work. At this junction down here at F, I2 and I3 adds up. So here's I2 and I3, and it adds up to give I1, right? So the direction of the current across the 1 ohm resistor is leftward. So let's mark the pluses and minus like that. So this is the first task that you need to do in the exam or in your any worksheet, so people can understand what you are doing. And after that we can pick a loop. So you can pick a loop like that and a loop like that, or you can pick the big loop A, B, D, E, A, right? So either is okay. So I am going to go with A, B, C, F, A loop. So let me write it, A, B, C, F, A. So you see A and A, meaning we have a closed loop and we are going in the clockwise direction. It doesn't have to be clockwise, it can be in any direction. It doesn't matter what direction you go, okay? But in this case I decided to go along that direction. So the sum of potential drops equals the sum of potential rises. I am not going to do the entire problem for you, but I am going to show you how to do it. So the potential drops. So let's go from point A to point B. So pay attention to the green dots. I am going to use the green, and then put the dots first at point A. It's not green. So here's point A and there's point B. So from A to B there is a 5-volt battery, and then you can see it is going from negative to positive. So that is a potential rise. So I am going to have it as 5 in the rises side. And then you have you are going from B to C. So there you have from B to C the 2 ohm resistor, and it is going from plus to minus, so it's a drop, and the drops are given by I times R. So here you have I, and the R is 2. Now we get into C, point C to point F, and then C to F we have 1 ohm resistor, again plus to minus, a drop, and that time you have I2 times 1. And then we come to F to A we have another resistor 1 ohm, and the current passing through that resistor is I1, plus to minus is another drop, so I have to put that in the same direction, drop direction. So let me erase this. and then write I1 times 1. So that is my full equation. So when I write it down in a nicer way that we all understand, here you have 2I1 plus 1I2 plus 1I1 and equals to 5. So you can see we have I1, I2 and I1. So we can combine these two together. There you have 3I1 plus I2 equals to 5. So this is my equation number 2 because I have named this as my equation number 1. And after that I am going to the next loop because we can't solve anything. We have I1 and I2 here in the second equation and I1, I2, I3 in the first equation, right? So we have to set up more equations. At least we have to have 3 equations to solve for 3 unknowns. Now I am going with F, C, D, E, F. Again a closed loop going in the counterclockwise direction. So the loop that I am drawing is the same loop that I have drawn in the middle of the FCDEF loop. So once again we put the potential drops equals to the sum of potential rises. So let's go from F to C, and as you can see, going from F to C, don't pay attention to the direction of the current. We have already used the direction of the current to mark the pluses and minuses. Now we are sticking with the direction of the loop. So going from F to C, we find a 1 ohm resistor and the current passing through that is I2. So you have it is going from minus to plus, therefore it is a rise. So we have to pick the right direction or the right side and put it in there, and that is I2 times 1. It's a rise. And then we are going from C to D. C to D you see 3 ohm resistor and the plus to minus, it's a drop. So we write it in the drop direction as I3 times 3. And then we have from D to E a battery, and there you have plus to minus, it's a drop. Therefore 3 volt is coming in on this side, potential drop side. And then the last one is going from E to F, and there you have a 2 ohm resistor and current is going from across the resistor. You have plus to minus a drop, and the drop is I3 times 2. So we rearrange the equation so in a manner you understand. We write it down 3I3 plus 3, and the other side you have I2 plus 2 times I3. So if you bring all the I2s, I3s to one side, then you will have 3I3 minus I2 minus 2I3, that is on this side, and the 3 is taken to the other side because that's just a number. And then we can combine the I3s together, 3I3 and 2I3, that will give you 1I3 minus I2, and that equals to minus 3. So this is our equation number 3. So we got 3 unknowns and 3 equations. Happy. And what you have to do is now look at the equation number 2. There you have I1 and I2, and here you have I3 and I2, right? So what I suggest you doing is use equation number 1. Let me bring it down here. The equation number 1 says I1 equals I2 plus I3. So this is again like middle school algebra substitution method. That's what I am going to use here. And because we have the 2 equations here, this equation and the equation down here, we should be able to solve these 2 equations. But the thing is that first equation over here, equation number 2 has I1 and I2 in it, and equation number 3 has I3 and I2 in it. So we don't want that. We just want the same like unknowns. So what I am going to do is I am going to take equation number 2 down here, and I am going to substitute for I1. And what is I1? I2 plus I3, right? So here let's do it. 3 times I2 plus I3 plus I2 equals to 5. Now I am going to remove the parenthesis and write it 3I2 plus 3I3 plus I2 equals to 5. And then I2's together, like terms together, so we can get them together, and you can have 4I2 plus 3I3 equals to 5. Now I'm going to call this equation number 4. We don't have to call it equation number 4 because it's the same as equation 2, only we did a substitution, right? Now if you look at equation number 3 from here, I'm going to use my blue pen. There you have I3 minus I2 equals to minus 3, right? So if you look at these two equations now, they have only two unknowns, right? I2 here, I3 there, and I3 there. So now we can use the substitution method and then find I3 from the third equation and plug it in the fourth equation. There you will be able to find I2. Once you know I2, choose an equation 3 or 4, plug the value of I2, there you will get I3. Once you have I2 and I3, equation 1 gives you I1. So that's basically the math section or the algebra part of these problems. I know even the students who are in electrical engineering section, still they are having a lot of issues with this algebra part, and that's why I decided to do this video. I decided to make it really quick, and it's about 12 minutes. All right.